Welcome to 4.8, using matrices to solve systems of equations. Start with some vocab. A matrix equation splits up our left side of our equation and our right side of our equation. And then it splits it up even further and it separates the coefficients from the variables, and that always equals our constant matrix. So we have a coefficient matrix, a variable matrix, and a constant matrix. We multiply the coefficient and variable and it equals the constant. So our first example here, we're going to write a matrix equation for the system of equations. First off, our coefficients are 5, -6, 3, and 2. Our variables are x and y. And our constants are -47 and -17. To write our matrix equation, we multiply our coefficient and our variable matrix, and we put an equal sign before our constant matrix. So here is our matrix equation. Next, this says solve a problem using a matrix equation, but here the idea is we're going to write a system of equations, and then we're going to set up a matrix equation for them. So first off, we're going to let C represent the weight of a carbon atom. Then we're going to let H represent the weight of a hydrogen atom. And the weight of an oxygen atom is just 16, as it tells us in the directions. So to set up the equation for glucose, we have 6 carbon plus 12 hydrogen plus 6 times 16, because there's 6 oxygen, that equals 180. 6 times 16 is 96, subtract 96 from each side, and we get 6C plus 12H equals 84. To set up the equation for sucrose, we have 12 carbons, we have 22 hydrogens, plus 11 times 16 for how many oxygens we have equals 342. Then we simplify. 11 times 16 is 176. Subtract 176 and we get 12C plus 22H equals 166. Next, we're going to write a matrix equation for the system of equations. So here's our system. The coefficients are 6, 12, 12, 22. The variables are C and H. And the constants 84 and 166. So we're going to add the coefficients equals the constant. You'll solve this matrix equation in exercise 11, so we're going to jump into solving systems of equations. So first, the first one here, you can write the equation AX equals B. For matrices, it's A times X, which equals B. So it's the coefficient times the variable equals the constant. 1 over A times AX equals 1 over A times B. So this idea is the inverse. So here the inverse of A times AX equals the inverse of A times the constant. X equals 1 over A times B, where 1x equals x, ix equals x. So the idea here with matrices, x equals the inverse of A times B. And finally, x equals 1 over A times B, right? Again, 1x equals x. The idea here is x equals A to the inverse times B. Example 3, we're going to solve a system of equations. So first, we're going to write the matrix equation, which is 6, 2, 3, -8 times xy equals 11, 1. Then we find the inverse of the coefficient matrix. So we do 1 over the determinant, and the determinant would be 6 times -8, so -48, minus 2 times 3, which is 6. We switch 6 and -8, and then we make 2 and 3 negative. So we're doing 1 over -48 minus 6 times -8, -2, -3, 6. 1 over -48 minus 6 is -1 over 54. We multiply this matrix. So we're doing this matrix, that's the inverse. We're going to multiply it by 6, 2, 3, -8 times xy. And then we can multiply it on both sides of the equation. So we're going to do the matrix times 11 over 1 as well. And so the idea here is that we get the identity times the variables, which is what we want. We're solving for x and y. which equals negative 1 over 54 times negative 90, negative 27. So that's after we multiply the matrices. And so therefore x equals 5/3, 1/2. Last example here, we use a matrix equation to solve the system of equations. So we have to write the matrix equation, which is 6, 8, negative 9, negative 12, times AB, which equals negative 18, 24. We're going to find the inverse of the coefficient matrix. So we're going to do the determinant, 1 over the determinant. So we're going to do 6 times negative 12 minus negative 9 times 8, which gives us 1 over negative 72 plus 72. Of course, that's 1 over 0, so the inverse does not exist. So the answer here, there is no unique solution of the systems. If we were to graph the systems of equations, since the lines are parallel, the system has no solution. Therefore, the system is inconsistent. Good luck on the practice.